Привет, and welcome to my session on how to build bulletproof enterprise applications for the hard production life. So a catchy title. Basically, a few things that I want to share with you, how to make our enterprise applications more resilient and more apt for the production life. Because it might be quite easy to build up some code, to come up with some solutions that somehow work, but running in production is always a different story, and things can go wrong quite quickly. So a few pointers that I want to give you today about that. About myself, my name is Sebastian Daschner, born and raised in Germany, and I work for this company called IBM. I do a lot of Java things, so typically I'm the enterprise Java space and so-called Java champion and all these other things. And another information about myself, ja lubię coffee. So this is why I have a coffee shop example for you, an example application that runs on Java Enterprise and that I want to take and, well, make a little bit more resilient together with you. So we're going to run that and I'll show you a few, well, examples where we could fail and a few resiliency patterns and also, of course, how they work internally. So here we go. I have two applications for you because one is boring, right? So they need some communication. And one is called Coffee Shop and the other application is called Barista. So we're going to build these applications using Maven and then we're going to run them in Docker containers and later on in the cloud as well. And I'll show you a bunch of things. So these are two applications built using Java E8 and one is called Coffee Shop, one is called Barista. So typically, if we want to order a coffee at that coffee shop, users go to the coffee shop, use an HTTP communication to connect to it, to send a coffee order, and then internally, that coffee shop application will talk to that second application, to that Barista backend. All right, and in order to build that up, we're going to run this using Docker containers, and then also I'm going to run it using a tool that is called WAD, Watch and Deploy. I will give you all these sources and everything later on, so you will get all the code and everything what I'm doing here. So this is a tool developed by Adam Bean where we actually can, this starts very good. Access denied exception. Perfect. So let's see, let's try this again. So what we're going to do, we run this tool so we can live code a little bit because, live coding is fun and things can go wrong on stage like you just saw. That's always fun to watch, at least for you. And then, yeah, perfect. What drop-ins? Oh, there we go. Okay, maybe that did the trick. So actually what I want to show you is some code that we then gonna change and test live away. So quickly what I want to walk through is that code that we're going to enhance with our resiliency concepts once that works, and then we order some coffee using this example. So what we have first, who of you is a little bit familiar with Java EE APIs such as JAX-RS? Hands up. Okay, a few of you. I hope it's going to be understandable what we're trying to achieve here. So what we have coffee orders in our system, right? We want to order some coffee. So we use, in this case, JAX-RS to offer some REST services where we can, order some coffee, right? So we're going to post some, in this case, JSON to this resource to basically say, order some coffee, right? Have some coffee for us. And what it does internally, we have a business component where we can say, order some coffee. And then what we do, we basically go there and say Barista, that is our backend system, start the coffee brewing process. And what I just told you, we have a microservice example of two applications. So now this is the first application, and the first one wants to call the second application and communicate with it. So have some HTTP client here, so that we take to communicate with the second system. And now, oh Jesus, okay. Let's try this out. Now that is not running. So what will we have? Temp, what, drop-ins. Okay, there's something wrong here. Temp, what, drop-ins. It's gonna do this. Maybe that works better. Okay, that's now empty. That should work. And which access does that have actually? Root, yeah, let's make this right all, right? That always helps. This is actually very funny because I tested that so many times, that script, and seriously, of course, when does it go wrong in front of a lot of people? Which is, yeah, that's life, I guess. So what that does, it actually deploys things to a running Docker container. I have some resources to show you how that works. And what I have my, in this case, OpenLiberty that runs this Java Enterprise application. So actually, it's not that interesting what I'm doing here. This is just for preparations. But what I can do using the script, it's very practical to say, I change something in the code, and then it automatically redeploys very quickly. So, you remember maybe the old times of something like WebSphere, where you had to, deploy and wait for like 30 minutes, an hour, hours, until that thing deploys. Thankfully, that's over, so we can simply change something in our code. For example, change something here. And then what this watch and deploy tool does for us, it listens to these changes, rebuilds our application, and if we have a modern application server that, well, it's not that quickly, actually. It should be a little bit faster. Well, 1 second is OK. So it redeploys our application quite quickly. And then we can go and, well, ask that application server to, well, now give us some coffee, right? So we have our coffee shop application, something like resources, and then coffee orders. So we can ask for coffee orders. And in this case, it says, well, great, 200, OK, it's empty. No orders in the system. Empty JSON array, right? So in order to change that, what you just saw briefly in the code, what we want to have, we want to order some coffee by pasting some JSON against that resource, right? So for example, a coffee type suggests cappuccino or espresso, right? We're going to post that, and if everything works, we have 204, no content. OK, great. There's now some coffee in the system, hopefully. Yeah, looks good. OK, great. Anyway. One of the first resiliency concepts that I want to show you, so that is now some code that more or less works, right? But it's not meant for production usage yet. And there are a few concepts that I want to show you how to enable that a little bit more. First one is timeouts. Whenever you do a connection to either an external system or to a database, which is also an external system, regard the timeouts once you have a synchronous connection. Why? Well, if you don't regard your timeouts, then there might be, depending on what you're doing actually, for HTTP client, for example, there might be a default timeout, or there are HTTP clients out there that actually have an infinite timeout. I hope you agree that's a really bad idea. That's like bad, right? Because what happens, well, you can have deadlock situations, right? So for example, what I want to show you here is that this is a very bad idea what we have. I mean, now everything works, right? We order some coffee, it works. But what if our second system, the barista system that we're accessing here synchronously, becomes unavailable? So how does our system then react to this error situation, right? And this is something that goes wrong and that will go wrong in production, and we need to take that into account. So a timeout is one of the things that we have. Let's do this, HTTP. No content, right? We can order more coffee. Let's do this a little bit more. No content. Here, order coffee, right? Let's do this. Oops. I just killed this one. Let's do this again. And again. So we're ordering a lot of coffee, right? We just had lunch. We're a little bit sleepy. We want to have a little bit more coffee. So what else we can do? Well, now if I go and say, oh, by the way, I'm going to stop the second container that runs my barista backend, just because. And then guess what happens? Well, we stop that barista backend, and then, of course, we throw some error. And, oh, you see that? Freezing, stuck, nothing's happening. Now it's stuck, and all of the 3 requests are blocking. What I do now is we want to analyze that situation. So what we can do with a JVM, we can send a quit signal, Unix code 3, to a JVM, to a process, and then it will dump the core. Let's now see what is happening inside. I mean, you can agree that this is a bad situation, because what happens, well, all these threads are blocking, these 3 threads, which doesn't matter because we have a bunch of threads in our thread pool, but what happens if all of them are gone? Then your application is doing nothing, but it does not respond anymore. Let's have a look at this situation. Actually, we're going to briefly show you what we just did here. So actually, there is now a core dump file, depending on the JVM that you're running, which shows you the threading situation and everything when I send that signal. And we're going to analyze that a little bit. User service, that's in the default. Here it is, Java core. It's in the directory where the process is running, and the Docker container is just a running Unix process, right? We can send signals to it, and it will act accordingly. So what that is, it is that core dump file. In my case, I'm running the OpenJ9 JVM. So depending on the JVM that you're using, we can have a look what is happening here. Let's search for the threads, right? Because what we're interested in this case is threads. We have a thread that synchronously executes something, and apparently it's stuck. So that's a good way. A thread dump is a good way to start that. It should be called default executed thread. All right, this one is just waiting in the thread pool. Okay, next one. This one is also just waiting in the thread pool. Waiting in the thread pool. This is interesting. Let's make this a little bit smaller. Socket connect, okay. It says, well, it has a lock here and it's waiting for it. So the thread is in a runnable state, but, well, it's blocked basically. And what we can have a look at is, well, look a little bit further down the call stack and we see, oh, barista send request. Interesting. Let's look a little bit further to default execute to the next one. That is again waiting in the queue. Oh, another thread. Runnable, but blocked or waiting here. That this currently at this stage. And what we see, again, if we go a little bit further, oh, barista send request. Interesting. Okay, let's look a little bit further. Oh, another one. Socket connect. Now we see a pattern here, right? Oh, looks familiar? So you see, all of these three threads are actually stuck at that situation, and we see they are in a state where they would be actually runnable, but they're waiting. In this case, waiting for the socket because, well, it's waiting for a timeout that is not going to occur. But actually, yeah, now it's actually occurred. So thankfully, our HTTP client, we just were relying on the default behavior. It has some timeout, but it came just way too late. Our application was stuck for quite a while. And this is one situation, first of all, how we can analyze that, using a thread dump, for example, core dump, depending on the JVM that you're running. And of course, well, now how to fix that in this particular case. Again, it really depends on what connections you're doing. Might be database connections, might be HTTP connections, like in this case. And what that is, well, HTTP client, right? That is JAX-RS client that thankfully, since version 2.1, supports the timeout configuration in a portable way. Before you had to specify some property files depending on the implementation that you're running. But now we can say do a connect timeout of 3 seconds just because for the sake of the example, and a read timeout for 3 seconds, whatever. And then, well, what we can have here, let's exit this. That was helpful. And now this is updating. And now what we have, well, if we actually start up our Docker run barista. If we start up our barista backend again, well, then we can see that this actually fixed the problem here in this case. So in any way, any connections that you're doing, be it database connections, any synchronous connections, just take these timeouts into consideration. That's one thing. Test it, test the behavior, and also have some processes in place that can analyze the situation quickly, right? So what happens in production if that happens? What you just saw, that the server is stuck, well, hopefully you have something in place where you can just say, okay, I have a process that starts, that goes to the application server, sends that signal, takes that core dump file, and restarts it quickly, right? So you have the information there, you can analyze it out of band, but then you're also restarting, in this case, the server, so that your users actually will have a responsive application again. And then at some point, all of that stuff works again, thankfully. So that's one pattern to take into consideration. Another thing that I want to quickly talk about is the so-called Bulkheads Pattern. Any of you remembers the Titanic, the ships, that hit the iceberg and crashed? Where do bulkheads come from? They come actually from ship construction. Bulkheads is a way how to construct ships, so you have multiple compartments in your ship body there. And once you hit the iceberg, then actually only one or two, a few bulkheads are damaged, and the rest of the ship stays intact, and you're hopefully going to make it to your harbor. With applications, it's similar. So we have this pattern where we can just define multiple compartments, multiple regions, if you want, functional compartments, where if one gets overloaded or crashes, the other ones are not affected. Fun fact, or maybe not that funny, actually the Titanic had bulkheads, but they weren't high enough or properly sealed enough. So, well, we know the end of that story. But anyway, for applications, that typically means thread pools, thread pooling. Why? We have our threads in our system, and what happens if our application gets overloaded? Well, then typically, we run out of these threads, and then the queues get overloaded, and the whole thing crashes. And what we want to make sure that even if we are in a microservice world, we might have multiple functionality, maybe multiple methods that are from varying importance, maybe, or at least we want to have multiple compartments where not all of that crashes. So that's the idea. Because what happens, I have at least two methods here, where let's just stop the two of them, where I basically say this is the order coffee method, right? And here what we have is, I'm gonna change this. It's just the get the coffee orders method, right? So the one on the bottom, it reads, and the one on the top, it creates new coffees, right? So what else we can do here is, I have a nice load script where I just say, oh, if I run my load test, then for fun, I overload my system, I hit it with a lot of requests, and then what happens, so this uses Fortio, a load test tool. Well, we once again slow it down. We're almost blocked. So we're now hitting the system with a lot of requests, and what happens out of the box, well, per default, it's just overloaded, right? So now you have to, and once the test is over, it continues. Now you have to know how typically these Java Enterprise applications work under the hood. We typically have a single HTTP request thread pool. A single, like in one for the whole application. That means if you hit your JAX-RS resource, this one, then typically, well, we have one request, HTTP request thread pool, where all of the HTTP requests are handled by a thread of that single thread pool. And once you overload one method, well, it hits that single thread pool, and you take the whole application down. So what we want to do, we want to define at least multiple of these request thread pools. So first thing first, what we can do, we can use a functionality by JAX-RS that is called asynchronous JAX-RS methods resources. How do they work? Since completion stage, since a newer version, JAX-RS 2.1, we can define a completion stage as a return type from whatever we want to return in our resource, and then this will tell the implementation, okay, now actually, if you invoke that method, don't take the request thread pool, but that will be suspended, and the execution will be done, inside of that completion stage, such as completable future. Inside that future, where you have, a different thread pool, for example. So what we have here is a completion stage here, and one here. We're gonna fix that code in a second. For the get methods, right? And also one for the write method or the coffee. Completion stage, so we can use that with the same types, for example, a JAX-RS response type, that works. And then, we're gonna change the implementation. And what I'm now gonna use, actually what I wanna have is that this business functionality needs to return these completion stage types also. And for that, and why I'm doing that is because I can use an extension. It's called MicroProfile fault tolerance. So the nice story about Java Enterprise now is it integrates with MicroProfile, so we can use the MicroProfile standards as an extension to our runtime. And what the fault tolerance does, well, it defines a few things that we might need. For example, MicroProfile fault tolerance is made for resiliency. And then if we add this to our dependency, fault tolerance, there we go, then we can use that API also if our runtime supports it. Nice story, it looks very much like Java Enterprise. So for example, we can have annotation-based handlers. I'm going to show you a few. And one annotation is called Bulkhead. Right? What does a bulkhead do? Well, it defines how many values, how many threads or executions we want to have. Depends on what type you use and how long the queue should be. So if we say value, let's say 4, waiting task queue 4 or 8, and if we annotate it as well with asynchronous, then we can use the completion stage type as a return type, and for example wrap it here into a completable future. And then what happens, the runtime will then automatically wrap it into an appropriate completion stage that uses an own managed thread pool. So then we literally have an own thread pool for this method that has a value of 4, so 4 threads and a waiting queue of length 8 in this case. All right, so what we're going to do is we're going to define that for all these methods. Completion stage, return, completable future, and so on and so forth. So nice typing exercise, right? Completion future. So you pay attention if I make any mistakes, okay? Live coding. We just saw at the very beginning what happens if you live code on stage. So if anything doesn't work, then it's also your fault. Okay, let's make these read methods with a queue length of 4, just for the sake of the example. So what we can do then, we can consume that completion stage type, and actually we can immediately, if we want, return it to the resource. So this is what we're doing here. Just return the same type, and that's fine. And here we say, well, get orders, that is basically a then apply to the orders.stream, do this, and then map it. Something like that, and then return the whole thing. So here we want to have a different type, a JSON array in this case. And what we're going to do down there is saying something like return this type and then apply the order and build response content type. Or exceptionally, if you have an error, then what happens is this, return that error and make this. All right. Looks good? Again, you're responsible for typos or errors as well. So if it doesn't work, also your fault. So looks good to me. Completion stage that tells us that we have an asynchronous JAX-REST resource. And, well, we use this functionality of MicroProfile fault tolerance, these bulkhead functionality, that also returns and actually creates internally the completion stage implementations using that thread pool behavior. And what we have then, once we can, redeploy it. Didn't work before because I was still typing. Now, let's see, built, yes, built successful, that's the thumb up. And we have reloading, yes, looks good, no content, 200, okay. And what we do now is, well, we actually want to hit that server with a high volume of requests again. And then what it does, well, it basically tells us a lot of status codes 503. Why 503? I'll show you in a second. So what we have, and that's the good news, the system, you saw it always stays responsive. We always get a proper response, but sometimes we get a 503 is a response. So what does that work? What does that mean, or how does that work? What I told it here, implicitly, the bulkhead type, or the bulkhead pattern here, what it does, what happens if a request comes in, or a thread comes in here, that cannot be fulfilled because the queue is already full? Well, we reject it. That one throws an error. We don't wait, we throw an error immediately. That's first of all a good story. Why? Because the queue is already full. That means all of the threads are working and the queue is full. So, we don't want to wait. We don't want to make the queue longer, but we basically, want to be served immediately. Following ASCII art picture, thread pool, of, in this case, 4 threads, and we have a queue. Now what we can imagine, well, the more threads we have, the faster it gets. The shorter the transaction time, the faster we can work on the individual task, like in the airport, the shorter it takes. Or the longer the queue we have, the more customers can we serve, but also the longer it will take. So now what we do by doing that is basically we configure how our system should react in this case. And we make it predictable, which is good. Because if you say you want to serve your customers for a specific SLA time, service level agreement time, below, let's say, 200 milliseconds or 20 milliseconds, then what we can do, we can calculate how long we should make our queues, right? Because the shorter it gets, well, then we can guarantee a shorter execution time, but we also immediately reject the request if it will not make that time. And that's basically what happens. So the science or the math behind that, it's basically a notation of back pressure, not on the client, on the reactive side, but on the server side, where we just tell a client, well, we are overloaded. And there are multiple ways to tell that client. This one is a very harsh one. We literally throw an error. We say, nope, come back later. But the good news about that is we immediately failing. We eagerly failing in this case, so we are predictable on our SLA time. We either guarantee that we're going to make it in that 200 milliseconds, or we're going to throw an error immediately, which is good because then the client might go to a different system and be still served within the 200 milliseconds. Because, right, the worst thing that we can do is like we had before, we make the client wait for a long time and then we fail anyway, right? That's the worst thing. So then we waited, you consumed all my SLA time and I didn't even get a response. So how we can calculate these, that's an example of queuing theory. You might have a look at the Little's law for that. It basically says, well, simple maths, our maximum latency divided by transaction time divided by number of threads. I mean, if you think about it, number of threads changes the whole story, the transaction time changes the whole story, and what we want to guarantee is a certain maximum latency so we can configure a queue length in this case, and that's basically the trick. And then what else I configured here was, where are we? Ajax-RS rejected execution handler to say that is the completion exception that comes from MicroProfile fault tolerance, where we say, please map this to, service unavailable. So this is why in my case we had 503 HTTP error, or whatever you want to do with it, right? But in this case we want to transfer it to the client, and then at least we stay, I can run it again if you want, and at least we stay predictable. And the whole system stays responsive. And in any case, you see that the write functionality was never, touched with that. It was not interested in that at all. We didn't impact it. So that's another thing to take into consideration. What else to be aware of when it comes to threading? And this is quite an interesting topic in Java Enterprise applications, because there is a reason why a lot of these specifications, if you read them, tell you don't start your own threads. That means don't start threads that are not managed by the container. So even if you do, something like a stream.parallel, what you do under the hood is using that default fork join pool, and that just creates the threads under the hood, which are also not managed by the container. But if you use standards or extensions to a Java Enterprise standard like this, then you're safe in that regard. You should regard your thread pools and queue sizes, and probably handle these rejected executions of whatever you want to do. In any way, for the bulkhead pattern, just make sure, keep in mind that you, out of the box, have a single HTTP request thread pool that you utilize in servlets or in Ajax-RS, for example. All right, so these are a few of the things for now. What else? Another resiliency pattern where I'm not necessarily the biggest fan. It depends where we can use them. Quite well known, I guess, circuit breakers, electrical engineering in the house. We want to make sure that we prevent further damage by not executing some methods or some functionality that are doomed to fail anyway, right? So if we know that quite likely an execution doesn't work because it didn't work the 10 times before, then we don't even execute it, but we immediately fail and throw an error, right? So if we try something, oh, didn't work. Okay, then we immediately retry, oh, didn't work. And then we immediately, didn't work. Then we don't try it anymore. in order to prevent the further damage. For example, not hitting an external system that is not available anyway. So what we can do here, that's also nicely supported by MicroProfile fault tolerance. I mean, basically what we want to have, let's take this method, for example. That's the client method. A lot of things can go wrong when we connect to that backend. And in this case, what we can do, we can wrap that functionality and do something like, an interceptor, right? Or another aspect that we can use in Java Enterprise or in Spring, whatever we use, right? And then you can write your own circuit breaker functionality if you know about the pattern. So try it. If it doesn't work, just check the error, then increase a counter, and after so many times, just fail immediately. Or we use an extension, and there's a nice annotation called circuit breaker, where we can define what we want to have here. So per default, we have a rolling window of how many requests we want to execute, and then if a certain percentage of certain ratio of them fails, then we open that circuit, and then we immediately fail, which means in this case that's the name is called request volume threshold. Per default, that's like 20, or we make 10 out of it. So in 10 requests, if we have a failure ratio of 0.3 of 30%, then just open the circuit and fail immediately. So if we fail forever, that's also a bad idea. So we want to close it at some point or half close it. That's the story. So after a delay that we can configure as well, for example, 3 seconds, then what we do, half closed state, we try it once. If it works, great, it's closed again. If it doesn't work, well, it's immediately open again. So we just try, oh, still not, and try again after 3 seconds, still not, and so on and so forth. So now if we apply that, okay, this works. Well, now it redeploys, but we don't have an error in our system, so let's just for fun build in an error. So you see that hot deployment is quite handy, which you can just like type something in our code and will be updated immediately. Do something funny like if new random next double is 30%, then of course throw an exception. Bang, right, great code, ready for production. So that is being copied. Let's try that again. So if that is now being redeployed, yes, then what we can do or what we can see, well, let's increase the volume a little bit more. That is, oh, actually that's the wrong one. This one is important. So internal server, another thing. So we can actually see stuff, grep-e HTTP, and there is a header field called error. So then you see, let's make this bigger, then you see the error. In this case, well, circuit breaker exception. What does it mean? Well, the circuit breaker is now open. It immediately fails. We do not even attempt it, but once in a while you see this bang. Let's make this a little bit slower. So it tries it for 10 times, but now if you have now this window of 10 requests where it fails in more than 0.3, 30%, then immediately it opens. And then what you see, it tries it again once. If it doesn't fail, no content, then it's good. If you try it again and it fails immediately, then what we saw before, then the circuit breaker would immediately be open again, right? So that's now the story about that. And then, of course, we can do something proper with that exception. The point is then we don't hit that external system that's not available anyway. And you can define, how you want to, let's remove this again, you want to handle these exceptions. So that's another resiliency concept in general, in this case implemented by MicroProfile fault tolerance or whatever criteria you want to define on your own. What else is there for Bulletproof Java Enterprise? In general, a few of the things that are just try to manipulate, try to test and hammer our application. You want to build up a test harness that depends on whatever you do in your application. So now if I have 2 applications, then you want to define test scenarios where, for example, this barista backend will be stopped. And then you see how that timeout reacted, right? Or where you hit your application with a lot of requests, maybe in a single functionality, where you make sure that the other functionality is still there, these Bulkheads Pattern, and so on and so forth. So just make sure that everything that could go wrong in production is actually going wrong in your test scenario, so you know how to react to it. And the next time you find something in production, a scenario that you somewhat, found that you ran into, then maybe you want to define a test as part of your test harness. Another common scenario, what I see in projects, is database connections. So try, and hammer these as well. Typically, what happens if your database goes down and comes back up again? Does your connection pool properly reconnect and all that? Data marshalling behavior. That's a nice story. How your data is being marshaled back and forth. In this case, you don't want to be overly restrictive. So there's this saying, be conservative in what you do and liberal in what you accept. So for example, if your HTTP client sends you, if your backend, if it sends you some data, for example, some JSON data, don't be overly strict in rejecting if, for example, you have a few unknown fields. Just ignore them. It's better. Why? Because then you're more resilient. If you have future changes in your application, if you have new versions of your backend that might send you more data so you don't overly fail. So don't be overly restrictive if you have all the information that you can use just to do the job. That's the important one of that one. And the last point, also very important, what I always quite often see, is extensive logging. If you want to kill the performance of your application, then log a lot. Like logging is the #1 performance hit. Why? Memory churn rates. You create a lot of string objects and byte arrays and all that. A totally different story, totally different talk. But if you want to improve your performance, just don't log. Log files are not interesting anyway. There are better ways around that. All right. A few other things that I want to show you that we can use now in a more modern scenario using cloud-native technologies in a cloud-native setting, where we improve actually the resiliency and the bulletproofness of our applications. So if we run something that runs, for example, on container orchestration such as Kubernetes, or uses a service mesh technology, we can leverage these technologies and improve our applications a little bit. So for example, yeah, that's still sending requests. For example, we have Kubernetes here. That's called production-grade container orchestration. That comes with a few concepts that help you improve that. For example, you have some controllers, and once an application fails, it's immediately being restarted. It's of course not great that the application fails, but at least it tries to maintain that target state that you define, and restarts it immediately. So what I have here, I actually have a Kubernetes cluster for you, where I have the same coffee shop application and just can deploy it. And where do you get a Kubernetes cluster from? Well, either you run it locally, such as Minikube, or you ask for a cloud environment. I use the IBM Cloud for a managed, please shut down your phone, for a managed Kubernetes server here that runs in Frankfurt or somewhere. And what I can do then, well, I can use this kube control, let's make this bigger, command line tool to say, please kube control, give me the Kubernetes services, right? Who of you is familiar with a Kubernetes orchestration? A few of you, okay, maybe not all of you. So who of you is familiar with Docker? Docker containers, yeah, that's great. So how do you run your Docker containers, right? In a production environment. You have a lot of nodes, hopefully. You have more than just a laptop, right? A few nodes, right? And how do you run them? Well, you connect to a node, say Docker run, right? Then you connect to a different node, Docker run, hopefully not, right? But I hope you get the story. It's quite an effort to run containers if you have multiple of these, and if they have to communicate with each other. You have to set up networks, maybe IP addresses and all that, and there's technology that does it for you. For example, container orchestration that literally orchestrates these containers across your cluster, and Kubernetes is one example. Let's go back here. Let's deploy this just for fun. Kube control apply deployment, kube control apply deployment of our barista application. So then we deploy our coffee shop and our barista application. Later on in the Q&A section, you can ask some questions if you have a few how that works with Kubernetes. We can talk a lot about that, but this is not a Kubernetes session per se. So we define, in this case, the so-called service and, well, a deployment that defines for us, we want to have one pod running workload here from that Docker image that we just built, one replica. right? We can scale that up to 10, how many we like, right? And that is a target state. So how that production-grade orchestration works, it always tries to maintain that target state. And that's one thing, and we have a few other concepts. For example, that service is a load balancer that distributes the load you have across your instances. Well, now I only have one, but if I had multiple instances, what do? Well, I just increase that number, and there you go. So anyway, what we now have is a few pods in our system that are just now starting up. Coffee shop and a barista pod, and a service, coffee shop and barista service, right? And once that is up and running, right here we can access it and actually ask for coffee in the cloud, right? Using that cloud native technology, same container that I showed you before that we can leverage now. So I can say curl, and then I use IP, use a secret script to get the IP address of my cluster, coffee shop, resources, orders, right? And then I just say, yeah, great, give me the coffee orders, no order in the system. So you know that story already. Then we order something in our application, espresso, right? This is how you write espresso. And then it says, oh great, 204, no content. So now I ordered some coffee, well, in the cloud, not that interesting. So what happens if some evil person comes and shuts down your pod? Oh, I have production access, I just delete that pod. And now it's down. Luckily, and that is one of the concepts, Kubernetes tries to maintain that state that you have. That pod is being terminated, but immediately you have a new pod starting up because it tries to maintain that state. Well, now that was the only pod, so I will have a downtime until that's up and running again, but at least it tries to maintain that state. Same thing if your image could not be found, it tries again after a while and all these things. So that is one of the concepts that where container orchestration helps you, have a little bit more resiliency in place. That's one thing. Another thing that I want to show you are service meshes, such as Istio. Who of you, there is that website, istio.io. Who of you has heard of the term service mesh or used them before? Hands up. Okay, well, even less. So what is a service mesh? A service mesh, like the name says, is a mesh of interconnected microservice deployments that communicate with each other and where we want to add some aspects that we might need in production. For example, observability or resiliency, which we want to show briefly, which we want to talk about. Or for example, some more advanced traffic routing. So what we have, for example, that is provided, we have some Istio resources here, and this what I just showed you, now it's up and running again. Okay, great. Now we actually have an Istio cluster, what I have deployed here, and then we can have some further traffic control or some further resiliency concepts. So one thing, and that comes with the routing here. That is the routing of this Istio resource. So if you're familiar with Kubernetes, this looks a little bit similar. YAML files where we can define the traffic routing in this case from the gateway where we have the cluster ingress traffic coming in, and that is so-called virtual service where we say, well, please take the all the traffic to our coffee shop and route it actually to, our coffee shop, right? So this is what happens there. So, originally not that interesting, but what happens under the hood is, in these service meshes, is that we have our Kubernetes pod that is running there with our workload, but instead of having only the main container in purple, or what is that, pink, we also have a proxy container in green. So the proxy container, so-called sidecar container pattern, this is how Istio works under the hood, can actually, enhance our communication with whatever we want to do with some more advanced traffic routing. For example, instead of going to the coffee shop or to the barista backend, go somewhere else, or add some, resiliency. See if our instances are even available, and if not, retry to a different one. So there are a few concepts that we might want to add here that can be interesting. So for example, one thing that we can do is we can add a timeout behavior by simply saying, well, this HTTP route, the destination where we're going to, in this case to the coffee shop application, that should be annotated with a timeout behavior. So our user wants to ask for a coffee, and inside, that hits the barista backend in a synchronous way. Inside, we have the timeout of 1 second, and if something takes longer, well, you have that timeout behavior already implemented by the proxy, which can be helpful. How do we use that? Well, we basically update it using the same deployment routing, using the same kube control functionality to say, well, update our routing. Now, where's my, do we still have some curl up and running? Let's do this again. While true, order some coffee. Curl, order some coffee. Oops. What is this? For HTTP, order coffee, right? And now order a little bit more coffee. So if I now applied my resource, then we have that timeout behavior of 1 second. Agree? No? Well, we don't see it, right? It's apparently faster than 1 second. So what we have here, we have the first connection that comes into our cluster that hits our coffee shop application, and that apparently now has a timeout of 1 second. Good, but we cannot test it. Well, what we could do now is make everything slower somewhat internally, right? You have the coffee shop application here, barista backend here. That has a timeout. What happens? Well, we could change the barista application into a faulty one, right? Such as a mock server. Agree? In a test environment, right? Or, even better, since we have that concept of the service mesh, where our application has that proxy, and all of these applications have these proxies, so the coffee shop has one, each and every part of the coffee shop application has that, and each and every part of the barista one has it. So these proxies, for test purposes, can mess things up. Because, in a test environment, we can say, by the way, where's our other routing? In this case, we want to make, that is now the routing to the barista service, second one. We want to take this route, that is the route where we just defined the timeout on the other service. But in this case, what we want to have, we want to insert some faults, just because we can, right? For example, we want to insert a delay, right? So we want to have a fixed delay of 3 seconds to make it slower, to test the timeout behavior of the first one, but not all the time, but only in 50% of the cases, right? So in that case, what we do, coffee, control apply, barista deployment routing. We apply this, and then what happens in our case, we get a gateway timeout after 1 second, right? So what was that? That was the first route that just said, please define a timeout after 1 second. And either, depending on how our barista backend reacts, either we have it immediately, the successful response, or we have a timeout, but after 1 second, but we don't wait for 3 seconds. So this is how we can test things. In general, so these service meshes, since we have that proxy behavior of each and every deployment, we can use these to test the resiliency of our application or of our whole system. So since these proxies can, mess things up, insert some faults. Same with error responses. We can insert some 500 error if you want. We don't have to redeploy our application like I did it for locally, right? So we can just say swap it out and now just return a failure here without changing the actual backend. And then, of course, we can undo that and then it works again. So that can help us for these in order to test the resiliency. So as a recap, what service meshes do, they transparently add some cross-cutting concerns to microservices. Observability is another one. Actually, tomorrow I'm going to have a bigger introduction to service meshes and Istio with Java Enterprise at 12-ish lunchtime. You can check the schedule sometime tomorrow if you're interested in that. And what else these service meshes do? Basically, think AOP, aspect-oriented programming, but for applications, right? AOP, that we use heavily in Java Enterprise and in Spring. Annotating something with these aspects now for the whole applications. So we can annotate applications with observability and, in this case, resiliency. What else is quite interesting? If we have some more advanced traffic routing. Another thing that I want to show you for deployments is, well, how we deploy our applications to production. And that also regards this container orchestration, right? And that is a big thing in bulletproof applications or in resiliency, because that is one of the failures in production is actually caused by deployments. Biggest, or from experience, most of the failures. Once you change something, things can go wrong. So what you definitely want to do, you want to define proper processes, how you roll out your applications, right? First of all, most important thing, try to define zero downtime approaches, right? Starting your application server and try to stopping your application server and try to start it up again is not a good approach, right? Because your users will hit some downtime. And maintenance windows and all that stuff, that's stuff of the past. In 2019, we should not say, hey, we have a maintenance window on the weekend or something. No, if you hit Google or Yandex or something else, you expect it to be up all the time, 100%. So that's an important one. So try to define some zero downtime behavior in general to not hit your user with the downtime. And then maybe you want to have a look into more complex rollout scenarios. So what I'm going to quickly show you to show another feature of this service meshes for the routing behavior is I want to show you a Canary Release. Where you basically take one version of your application that you have and then you roll out a new version. Simple. But you basically do not roll it out as a big bang approach, even with zero downtime by just switching. But what you do, you gradually switch. You might have 5% of the traffic goes to the new version, and then a little bit more, and so on and so forth. So what I'm going to do now here is delete default resources. I'm going to delete everything in my cluster again. So you see I'm a big fan of scripts, so that's faster. So then my pods are terminating now and shutting down, and then I can deploy a new version, deployment, where I have that example for you. And basically what we want to have, well, we want to define a more sophisticated approach, and I built a script here that you can also have a look at later at the resources. So first of all, we want to deploy version v1, where our application says, well, hello at some point. And then we want to deploy a new version of that, but with that Canary approach, where we don't do a big bang deployment at first, but a gradual one. Let's have kube control get pods, and let's have a look at them. Watch this. That's a little bit too big. So we have one pod that is up and running now, and what we do, well, let's try to hit our application. Curl. So this one responds again. Let's, in this case, ask the health check resource. That includes an app version, a little bit bigger. So let's ask for this. Grab app version. And again, ask a few more times. Just hit that, and right now we have a version 1. And what we then also have is deploying a Canary Release where we say, what is the old version? And version means, in this case, the subset of the deployment here. So what we define using this Istio service mesh approach, we can define subsets of services actually. So divide our services. For example, the coffee shop service, it's still the same coffee shop application, the logical question of that coffee shop application, but we divide it further into multiple subsets, into multiple versions that we can then switch accordingly. So what happens, saying use this, now you see version v1, and now the new one is v2, and it has a new image version, the Docker version, and then it tries to roll that out. And how that works is, well, it deploys a new Kubernetes version first where we have a new pod, coffee shop v2, totally different independent Kubernetes deployment, where we just deploy that here, and then we try to wait until that is up and running, totally isolated from the first one, and that is typically how you deploy, how you realize zero downtime deployments, right? You have some blue-green deployment approach in one way or another. Might be realized using Istio and service meshes here, might be your own implementation, your homegrown framework, whatever you do, you try to, build something up while the other version is still running, so then you can make the switch without disrupting somebody. And once that is the case, then we're routing gradually 5%, 10%, 20%, and then you will see in the command line that, this is kind of random, but then more and more requests actually will hit the new version, app version 2, until we fully roll out 100% to the new version. And again, what I want to show you here is basically trying to define a proper and automated approach where you have a rollout strategy. And include that with some, observability, with some metrics in the background. And if you're interested in that, again, tomorrow is a session where you see where this is actually also added by Istio already, where you see, okay, what happens now to this version 2, to these 5% that you run in production? Does the new version immediately explode and crash everything in production, right? If so, then at least you only impacted, there's a notation of called blast radius, 5% of the users, and not everybody, like you would do in a Big Bang release, and you can immediately roll back to 0%, right? You can immediately switch back. Also in an automated approach, that's the idea. If not, then you go to 10%, 25%, to, define a range. And the point is, have an automated approach. Don't do that yourself, but at least have some, kind of scripting, automation in place that does it for you, and that also rolls back in case something goes wrong. And then, your users will be more happy, and you have more resiliency in place. So that's basically a few of these key takeaways that you have. In general, try to, consider timeouts that you have for all of the connections in your system. Try to apply some resiliency patterns, circuit breakers, bulkheads. See how for the bulkheads behavior your threading works internally. So mind, the container defined request thread pools, and in general, know your implementation. Whatever you're using, if you use some kind of application server or a Spring or any other Java Enterprise framework, know what that thing is doing inside, because it does matter. Ultimately, your applications will run in production, and that is, that is the question. What does it do here? And for your approaches that you should apply, always test it. Always test the worst-case scenarios and define some testing scenarios, whatever they do. There are a few technologies that help you here. For example, things like quick deployment strategies that I showed you locally, or containers that it can quickly start up, that it can shut down, that it can replace with something else. Or what we saw in a production-like setting, container orchestration and service meshes, things like that. And try to automate as much as possible the processes that you do. For example, for investigation, for analysis. What I showed in the very beginning with the threat dump, have some process in place that does it for you and try to get that information so you can analyze it out of band later on while your application has already been restarted, so that your users are happy again and you can analyze the situation, what happens. And automate that because it's much quicker than a human could do, right? And these service meshes can help you. For example, the resiliency that we have in place, there are a few concepts there, can act as a fallback to your application resiliency on a connection level. And these service meshes can also help you to test the resiliency. For example, introduce things like, there's a notation of chaos engineering, of saying, okay, I now on purpose want to mess things up in order to test how my application reacts to it. And then your application's resiliency gets better and better. And that's ultimately the idea. Use automation and proper processes to improve the bulletproofness of your application. I hope that was helpful. Spasibo, and thank you very much for your attention.